As part of Thermax Cooling Solutions Limited, we offer wet and dry cooling solutions that use air, water, or both to remove heat. Cooling conditions play a critical role in the manufacturing process. The right solutions ensure that the raw material undergoes precise temperatures at different stages to deliver a flawless product. Our wet cooling solutions include evaporative condensers, closed-loop cooling towers,
adiabatic cooling towers.
Our dry cooling solutions comprise air-cooled condensers, dry coolers, air-cooled heat exchangers. We take pride in our evaporative condensers, a leading solution from our impressive line of products for the myriad benefits it offers to diverse industries such as ice cream and ice factories, seafood, dairy, cold storage, chemical, food and beverage, and pharma. The indigenous range of evaporative condensers sold under the brand name Exonity is designed to reject refrigerant heat,
ammonia,
and all varieties of modern refrigerants at varied climatic conditions. Apart from quality and 24/7 support, our EVCs ensure minimal, effortless maintenance, low energy consumption, faster installation on site, lower operating cost, reduced carbon footprint, extended service life. The conventional condensers come in the form of traditional coil bundle with civil structure, or a combination of either a plate-type heat exchanger or shell and tube-type heat exchanger,
and open-loop cooling tower with circulation pump.
Our innovative evaporative condensers integrate the intermediate heat exchanger, secondary pump piping, and open-loop cooling tower into a single unit. Available in two variants, mixed flow and counter flow, we offer our customers better capabilities and a seamless performance. While both have a similar operating principle, the difference lies in the way the air is treated and the subsequent impact it has. Mixed flow EVC. In this type of EVC, the refrigerant is circulated through the coil of the evaporative condenser. Heat from the refrigerant is dissipated through the coil tubes. The heat is removed directly by the downward natural induced air, aided by a spray of water cascading over the tubes. Simultaneously, air is also drawn in through the air inlet louvers at the base of the condenser and travels through the heat exchange fills at a direction perpendicular to the direction of the spray water flow, where the water is evaporated, removing the heat and cooling the spray water. The warm, moist air is drawn sidewise by the fan and is discharged into the atmosphere. The remaining cooled water falls to the sump at the bottom of the condenser, where it is recirculated by the pump up through the water distribution system and back down through the coils. Counterflow EVC. In this type of EVC, the refrigerant is circulated through the coil of the evaporative condenser. Heat from the refrigerant is dissipated through the coil tubes. This heat is removed by the spray water cascading downward over the tubes. Air drawn in through the air inlet louvers at the base of the condenser travels through the heat exchange coil at a direction opposite to the spray water flow. The water evaporates, removes the heat, and cools the spray water. The warm, moist air is drawn by the fan and discharged into the atmosphere. The remaining cooled water falls to the sump at the bottom of the condenser, where it is recirculated by the pump up through the water distribution system and back down over the coils. Through an ever-evolving culture of innovation, Thermax continues to offer solutions that enrich everyday lives. Call us today to experience Thermax and understand why the name evokes reliability and trust.